Hello friends, in this session we will understand how to convert galvanometer into ammeter. Okay, now in the last session we have understood the construction of galvanometer, the working of galvanometer, how does galvanometer work, right? So on the basis of that, what can we conclude? Number one is that the resistance of the galvanometer, this resistance of the galvanometer is very sensitive. That's the reason why it cannot measure high amount of current. Let's say for example, currently this galvanometer can measure only 1 ampere of current. It is just an example, right? Practically, galvanometer measures current in microamperes. But for simplification, we will consider that this galvanometer is measuring 1 ampere of current, right? So that means this galvanometer cannot measure a current which is greater than 1 ampere. Why? Because if we are passing a current which is greater than 1 ampere through this galvanometer, the resistance of the galvanometer will get damaged. The galvanometer itself will get damaged. So this current which is 1 ampere will be called as full scale deflection, right? So this 1 ampere is the maximum current through which can be passed through the galvanometer. So this is 1 ampere, which is also called as Ig. So for example, we are taking Ig is equal to 1 ampere, and this Ig is also called as the full scale deflection, of galvanometer. Right? So that means if this is the galvanometer, this galvanometer 0, 0.5, 1. So the full scale deflection of this galvanometer is 1 ampere, right? Okay. So number 2 that we can conclude is I is directly proportional to theta. Right? That means if the amount of the current which is passing through this galvanometer is greater, then the deflection in the galvanometer will be greater. That means I will be directly proportional to theta. On the contrary, I can say it is Ig which is directly proportional to theta. That means if Ig is greater, then theta will be greater. If Ig is smaller, then theta will be smaller. That means galvanometer will show the deflection only for the current which is passing through its own resistance. Once again, galvanometer will show the deflection only for the current which is passing through its own resistance, which is considered to be G. Right? Okay. So these two are the very important conclusions. Okay, now we will understand on the basis of this how to convert a galvanometer into ammeter. So again, this is the resistance of galvanometer. Okay, the resistance of the galvanometer is G. Let's say for example, just for an example, the full scale deflection of galvanometer, which is Ig, is equal to 1 ampere. That means I cannot pass a current which is greater than 1 ampere through this galvanometer. If at all I am doing so, the galvanometer will get damaged. Right. However, I desire to find 10 ampere current. I want to measure a current which is equal to 10 ampere. Right? That means I actually want to convert this galvanometer into ammeter which can measure the current of 10 ampere. Okay. If I want to measure a current of 10 ampere, what do I require to do? I cannot pass 10 ampere through this galvanometer. Why? If at all I am doing this, galvanometer will get damaged. Now, in order to make this galvanometer measure 10 ampere current, I require to join a resistance in parallel to this galvanometer resistance. So, I am connecting a resistance parallel to this galvanometer resistance, which is also called as shunt. Now, please understand, the resistance of this shunt is less, very less than the resistance of the galvanometer, right? Resistance of the shunt is very less as compared to the resistance of the galvanometer. Now, I want to measure the current 10 ampere. I want to convert it into ammeter which can measure the current of 10 ampere. So, what current am I passing through it? 10 ampere. Right? Now, I am choosing I am having a shunt in such a way that maximum current will pass through the shunt. Why? Because shunt is having less resistance. Less resistance, more current. More resistance, less current. So, what will happen is maximum current, that is 9 ampere of current, will pass through this shunt and 1 ampere of current will pass through this galvanometer, right? So, earlier, what was the full scale deflection of galvanometer? 1 ampere. Now, what is the full scale deflection of galvanometer? 1 ampere. That means, is the coil of the galvanometer been damaged? Is the galvanometer been damaged? No, it is not open to damage. Why? Because it is 1 ampere. Still, the galvanometer is, still the current which is flowing through the galvanometer is 1 ampere, right? So, I have saved the galvanometer, right? But what about deflection? Earlier, the deflection was for 1 ampere. So, this is 0, this is 0.5 and this is 1 ampere. So, the galvanometer was showing the deflection of 1 ampere, right? 1 ampere. But now, what is our second conclusion? Ig is directly proportional to theta. That means galvanometer will show deflection only for the current which is actually passing through its own resistance. What is the current which is passing through its own resistance? 1 ampere. So, how will it be able to show the deflection for 10 ampere? Right? What I will do is simply change the calibrated scale of the galvanometer. So, what was the earlier calibrated scale? It was from 0 to 1 ampere. Now, I will simply change the calibrated scale. It is now 0 and this will be 5 ampere and this will be 10 ampere, right? The deflection of the needle will be the same, na? Ig is directly proportional to theta. If Ig is equal to 1 ampere, theta is this, right? From 0 to this 1 ampere, this is nothing but the theta. Now, in this particular case, the theta will remain the same. But what have I done? I have changed the calibrated scale from 0 to 10 ampere. This was what? 0 to 1 ampere. Actually, the deflection of the needle is what? Same. But the calibrated scale is now different. So, what is this needle showing now? It is indicating 10 ampere. So, what have I done? I have passed 10 ampere current through the galvanometer. But inside the galvanometer, only 1 ampere current is passing through the resistance of the galvanometer. That's the reason why the deflection is in accordance to the 1 ampere current. However, since the calibrated scale is been changed, apparently it will show that the current is 10 ampere, right? So that means I am manipulating the calibrated scale in such a way that this calibrated scale, this galvanometer will show me the current for 10 ampere, and I am actually have converted galvanometer into a meter. Okay, now let us form the equation for this so that we can manufacture this calibrated scale in accordance to the equation. Okay, so I'll take the generic values now. This current is nothing but the current which I want to measure, which is obviously huge, which an ammeter can only measure, right? So this is the current which I require to measure, which I desire to measure using ammeter. Okay, now this is the value of shunt S and this is the value of galvanometer, resistance for galvanometer. Galvanometer cannot have current which is more than its full scale deflection. So the current which will be flowing through this is Ig, and the current which will flowing through this will be Is, right? Okay, now since this galvanometer resistance is parallel to the shunt, I can say that the potential difference across both will be equal. Okay, before that, can I say that I is equal to Ig plus Is? Yes, of course, right? Okay. Now, I can say that the potential difference is same. So, Ig into G is equal to Is into S, right? So, I can write S is equal to Ig into G upon Is, right? Okay, what is Is? Can I write Is is equal to I minus Ig? Okay, so I can write S is equal to Ig into G upon Is is I minus Ig. So this is nothing but the value of shunt which I require to substitute, which I require to have at this particular point, so that only Ig amount of current passes through this galvanometer when I pass current I from this branch, right? Okay. Now, in the same way, I can also find equation for Ig. So I can write Ig is equal to Is into S upon G, right? Okay, so what is Is? Is is equal to I minus Ig. So I can write Ig is equal to I minus Ig into S upon G. So I can write Ig is equal to Is minus Ig into S upon G. So I can write Ig into G is equal to Is minus Ig into S. So I can write Ig into G plus S is equal to I into S. So Ig is equal to I into S upon G plus S. This is the equation for Ig.